Alright, I just got my N-channel MOSFETs in. Got 6 for $10. The N-channel MOSFET goes right here, and that's to repair this 30 volt 5 amp DC power station. This power station malfunctioned when I tried to test an H11 4.5 amp 12 volt bulb. I was making a load tester for a car, and this right here, it has some issues, but I'll discuss that in just a moment. Now I've got my meter set on diode, and I'm checking these MOSFETs that I just got in the mail. And anyway, put the black lead on drain and the red lead, and you get this. I apologize for the poor. Alright, black lead on drain and red lead on source, 0.5. Then you switch the leads. Put the red lead on drain and the black lead on source, and you get OL. That's a good MOSFET. Now I'm going to check the MOSFET that I removed from this power source. Okay, black lead on drain, red lead on source. You heard the meter. Now switch, red lead goes on drain and black lead goes on source. Okay, defective. I've checked all the other components on this, both on the primary and the secondary side. I'm going to put a new MOSFET right here. Then I'm going to put this back together and plug it into my, you can see that this is my dim bulb tester. It goes all the way up to 400 watts, but I'm only going to put it on about 140, maybe 120 watts when I first turn this thing on, because this thing spikes. It has a surge, and I believe that's why I had the component failure. That's one of the flaws on these power surges, on a good many of them, is that it has that initial power surge influx of current, and that's where some components are damaged. So from now on, when I do use this, I'm going to have it plugged into my dim bulb tester to help alleviate or offset the initial power surge to avoid future damage to any DC appliance or part that I'm trying to fix. Okay, I've mounted the N-channel MOSFET. Okay, let's put the positive lead on the drain and the negative lead on the source. Okay, 0.5 DC volts. That's good. Now we'll reverse them, but what you got to know is there are some 1,000 microfarad capacitors hooked to this drain right here. There's 2 of them, so you're not going to get an OL. So here we go. We reverse the leads. We put the black on the source and the positive on the drain. I'm just going to put the drain right here. Okay, notice the meter. Those are those 2 those are those two 1000 microfarad capacitors, electrolytic capacitors, wired in parallel that are registering right there. Alright, let's move on. Got it all assembled, the Variac. Okay, we got it. Good voltage. Okay, I figured out the problem. This thing takes more than 120 watts. It takes at least 160 watts. That's why it didn't turn on. So I'm going to turn it on. I'm going to turn on one more bulb here. Let's go with number 6. Alright, that's 160 watts. We're going to turn this thing on now. No, still won't work. Wow. Figured out what's going on. Let me show y'all. Okay. Got it set on AC. This is my dim bulb tester. Alright, gonna put, it doesn't matter. Okay. Okay, got 120 AC volts. Alright, now plug this thing into the back of here. Right in. I've already checked the fuse. Fuse is fine. Plug it in. It's plugged in. Now, watch this. I'm going to put red there, black on ground, right there. So, I'm thinking there's something wrong with this plug here. I need a new plug. So this project's on hold again. Dadgummit. Alright.